Hi there. My name is Aaron Lanterman. I'm a professor of electrical and computer engineering at Georgia Tech, and I'm in the process of learning the KiCad PCB layout software. Today, I'm going to try making a custom symbol for the first time. I need to make a symbol for the LM3900 Norton amplifier. These are not regular operational amplifiers. They have current inputs instead of voltage inputs, so I don't like using the op-amp symbol. I want to use this symbol from LM3900, although I'm not going to use the arrow on the plus terminal here. I do want the circle with this little arrow here. I find this symbol misleading. It makes you think this is a current source, which is not. These are separate current inputs. It goes to a current mirror. Actually, would people be interested in a series of lectures on Norton amplifiers and what they are and how to use them? If so, leave a comment below. Let me see if I can modify a quad op-amp symbol. Okay, TLO74. Can't edit this? Oh, derive from symbol, LM2900. So maybe I need to edit an LM2900. Okay, LM2900. Here we go. Is that a quad? Yeah, that's a quad. And here's the power. Oh, there's a place here to put the documentation. Let's copy this here. SNOA. Okay, did that happen for all of them? Okay, and I guess there's some documentation here as to what it actually is. We'll say it's a quad Norton amplifiers. DIP 14. I don't know if it comes in a SOP. I doubt it. All right. Okay, let's go to Unit A. Can I stick a circle here? How about something like that? And is this a polygon? Let's see. Let's right-click, get to the grid, change it to 25 mils. Whoop. My circle went away. I guess I accidentally undid it. Let me put the circle back in. And here's the polygon. The arrow points to the positive terminal according to the convention. Double click to end. Okay. And let's see if I can click on, no, I don't want the pen. I want to click on that. And let's change the color to fill with body outline color. Okay, now is there an easy way to copy this whole symbol to Unit B, to Unit C? If anyone knows a way to do that automatically, please leave a comment below. In the meantime, how about I'll just grab this stuff, select copy, go to Unit B, paste, and let's go to Unit C, paste. And we go to Unit D and say paste. Okay, I think that's all of them. Okay, now I need to fix the pins. The pin layout of a 3900 is very weird and not at all like a standard quad op-amp. Okay, so positive for what we'll call A. This is pin 1. The negative is pin 6. Whoop, that's not what I meant to do. Negative is pin 6. The output is pin 5. Whoop, not that one. No. Cancel. Output is pin down here, pin 5. And for Unit B, we'll say the input is pin 2. The negative input is pin 3. And the output is pin 4. Unit C, let's see, that's amplifier 3. So the input pin that's positive is 13. The negative is pin 8. And the output is pin 9. This is such a weird layout. All right, and then D, we have pin 12 as a coincidence. That's the same. Pin 11 is the negative input, and then the output is pin 10. And then let's go over to unit E, which is the power supply pin. So this is more like a traditional logic chip is set up. So I guess that kind of makes sense. Let's see, this is pin 14 for the positive rail and pin 7 for the negative rail. And the way it's listed here on the data sheet, this is as ground, but it's really whatever the negative rail you want is. So I'm just going to call it V minus here. So let's try it out. This is one of my templates that I've made for the Tangible Ways format. Once I refine these a little bit, I'll stick these on my GitHub so other people can use them. So let's add an LM3900 from Aaron's library. Doop, 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 doop. Okay, so let me double click on this and let's assign a footprint. Let's see, package dip, and here's SOIC, but we want the dip. Let's pick this one. All right. Okay. And now if I go over here, I should be able to say update PCB from schematic, close. Here's my chip. And let's just think about power for a second. Okay, so let's copy this 5 volt, the positive here, and this ground over here. That's powering up the chip. You would also want to put a bypass capacitor here. Let's see. If I now update PCB from schematic. So one thing I don't like about KiCad is you have to keep manually updating, it looks like. Okay, so it looks like this more or less works. Let's grab a resistor and maybe toss it in the feedback loop just to make sure that kind of thing works. Copy, paste. Let me move this down here and actually let me flip that. Oh, this kind of looks ugly, doesn't it, with the number right here, but we'll live. All right, let's put this here. I'll wire resistor here in the feedback loop. Let's go back here to the board, update the board. Again, I would prefer it automatically do this like an eagle. Okay. So I might do something like M for move, stick this here, or maybe I would stick it here. Actually, typically the way I would like to do this is I like to take the feedback resistor and put it at the output pin. So that would be pin 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah,